How I got into this is an interesting story. About 10 years ago, I began teaching a class at the University of Chicago for first responders and emergency managers. And the title of the class was Complex Adaptive Systems for Threat Management and Emergency Preparedness. So teaching this class presented me with a problem. The problem was I had no idea what to say or why people would be interested in what I had to say. But then it occurred to me in looking at the emergency planning guidance, the legislation, and what was provided to first responders and communities in regard to emergency planning was incomplete, because these documents and procedures had been developed at a high level. But at some point, it was up to the individuals on the ground to fill in the details, or simply to experience an emergency to understand exactly what they had to do and what decisions they had to make and what questions they had to answer in real time. So I discovered that a way to think about the entire problem was to realize that we are parts of and embedded in and dealing with what is generally called complex adaptive systems. So the goal of my talk is really to help you apply systems thinking to your work in emergency preparedness. And I would ask you to do one thing while I'm talking. I'd like you to consider whether you are a systems thinker or not. And at the end, I'll ask to see who is a systems thinker. We live in a world of increasing complexities, of course. The rate of complexity is increasing at an ever-expanding rate as well. But I should tell you what a complex adaptive system is. It's any system that consists of a large number of interconnected components. Sometimes we call them agents that interact and adapt and learn. We are all part of complex adaptive systems, whether it's being part of the organizations that we are all members of at work or even socially, or dealing with the infrastructure and the connected infrastructures, lifeline infrastructures. But the point is that we need to understand complex adaptive systems to really anticipate what the outcomes are of emergency preparedness actions and responses, as well as what the interventions could be that could be helpful and not counterproductive. You probably already know something about complex adaptive systems because our social language includes many terms that have to do with complex systems. Things like tipping point, turning point, nonlinear behavior of systems, phase change. Sometimes we talk about sea change to indicate a change in our organizations or our outlooks or perspectives. Feedback or blowback, things that we do that come around to bite us. The domino effect, cascades, emergence even, collective distributed intelligence or swarm behavior. These are all behaviors that we can relate to as observing in everyday life. Endogenous versus exogenous, meaning endogenous is inside the system, determined. Exogenous means determined from the outside. And finally, top-down, which is a lot of how our planning has been done traditionally, versus bottom-up. And bottom-up is the notion of decentralization. Decentralization means that decisions are made in a decentralized way. There is not an overriding central authority that determines everything. And the lessons of complex adaptive systems tell us that we have to consider this decentralization effect that not only exists, but our society is becoming more decentralized as we go on. One way to think of a complex adaptive system, and I want to put a vision in your mind, is as a network. A network has nodes and links. And the nodes in the network represent decision-making, decision makers. The links in the network represent the relationships between decision makers. For example, links could refer to communication links and information flow, or it could refer to some kind of command and control structure, authority from one node to another. So whether the system is people evacuating an emergency, or the infrastructure, the electric power grid connected to other lifeline infrastructures, or, as I said, the organizations in which we're members of, we can all represent these systems as a network. So in any emergency, there are repeating questions that occur. And we can learn from those questions. Some of them are recurring over time. Some of them are new to the situation. But the common element in the systems that we have to answer the questions about has to do with people's behavior, how they behave. Either they make decisions or they are reactive in their behaviors. So we need to understand from the complex adaptive system, let's say network perspective, how we can capture the lessons learned of behaviors as we go through from one disaster to another, and have a repository for that information. The techniques in which we so-called model complex adaptive systems will allow us to have a unifying framework for this information so it can be used again and built upon in our planning decisions as we go forward. Understanding complex adaptive systems requires some tools. I mentioned network analysis, very useful technique, which can be done qualitatively. One can simply think of drawing a picture of the important decision-making organizations, for example, and how they're connected and information exchanged between them in advance of an emergency. So we've done this for many situations where we've scoped out all the organizations involved in their communications protocols and who should interact with who. We did find also, of course, that what's kind of written down in the plans as an organizational structure of decision-making can be completely different than what actually occurs in the real world in the event of a disaster or an emergency. These ad hoc networks can emerge and be created. Other techniques have to do with causal modeling. System dynamics is a technique you may have heard, which looks at the factors that are responsible in a system producing its behavior step by step. Optimization is another approach in which we consider what the objectives are of what we're trying to do, what the constraints are and resources, and put that together into a systematic, interweaved framework. Finally, agent-based modeling, which was mentioned, is an area that I've spent most of my time in for the last many years. And so the notion of an agent-based model is to take a bottom-up approach and represent individuals in a population along with their key characteristics and their behaviors or decision-making behaviors that they have. As people progress through their day, they engage in activities and can also be considered to have behaviors in response to external events or what they simply want to do. So we can think of applying the same techniques of agent-based modeling to modeling, as I said, what happens during an evacuation, but also what happens during a terrorist attack, for example. Whether it's modeling the terrorist or modeling a response to the terrorist or the population, all of these factors can be considered now really for the first time. And the reason for that has to do with we have more data. And also we have more powerful computers as well. We've developed a model for Chicago in which every individual person is represented as an agent, and their behaviors and activities as they go through their daily routine are explicitly modeled. We don't really have data on real people, but we have data that we've downloaded, so to speak, from the Census Bureau and applied that to virtual agents in cross-tabulation procedures. So statistically, everything adds up on a variety of characteristics, just like the real population, but there's no single individual that has those exact data values. With such an approach, we can model the individual social contexts of people and where they go during the course of their day. This has an application, for example, in the work that we have done on preparing for pandemics. So in 2014, as you recall, there was an Ebola outbreak in West Africa, and it affected primarily 3 countries, Liberia, Guinea, and Sierra Leone. There was one case in Mali as well. What we did was to do a systems analysis of not the Ebola outbreak in Africa, which many people were doing, but we did a systems analysis of what would happen or could happen if Ebola came to the US. And so what we're seeing here is an Ebola circulation model, which really indicates all the ways, or the 2 ways, that Ebola could enter Chicago, for example. At the time, there were, I believe, 5 airports in the US that were designated as able to receive flights from the affected countries. And in Chicago, there were 4 hospitals that were designated as being able to receive Ebola patients or suspected Ebola patients. We did analysis of the possibilities using many, many scenarios, thousands of scenarios of what could happen and be possible using different, let's say, assumptions about data items and various parameters. In the end of our analysis, we were able to search through many situations and scenarios and find a good intervention that reduced the potential number of people affected in Chicago from millions to simply hundreds in the best case. There were many assumptions in this exercise and model, and nonetheless, the tools that we applied revealed many things. For example, in Chicago, as I said, there were 4 hospitals, but they were able to receive Ebola patients. And I may have mentioned that 10 people actually went through the screening and were, let's say, detained at O'Hare Airport because they didn't pass the screening. None of them turned out to have Ebola, but they had other illnesses that looked very similar. And we were able to, easily find out that the total capacity for Ebola patients in the entire city of Chicago was basically 8 because of the high requirements for resources and space and healthcare providers and personnel that are required. That was the entire capacity. So this kind of information is helpful to understand what the resources are that are required in case we have such a event. Another area that is really interesting to look at and view as a complex adaptive system concerns lifeline infrastructures, but not only individually, such as the electric power industry and transportation, communications, et cetera, but how these infrastructures are connected together, creating even greater interdependencies than we had with any one infrastructure alone. Critical infrastructures, which you see here on the screen, are represented and have many, many interdependencies between each other. For example, electric power supplies electricity to water pumps, which are necessary to bring water to the community. By the same token, water is needed to cool electric power plants and many other dependencies like that. So one of the areas that we looked at and are continuing to look at is the vulnerabilities that are introduced by infrastructure interdependencies. The biggest interdependency we have now in our society is the one between natural gas and the supply of natural gas to power the electric power systems across the US. Natural gas is cheap, and a lot of power plants are being converted to be being fueled by natural gas. This interdependency, though, between gas and electric power creates a loop in which a disturbance or disruption in one infrastructure can disturb another infrastructure and have cascading events over time. So we've done various scenarios to identify these vulnerabilities and discovered, so to speak, that a disturbance in the electric power grid can lead to a shutdown in the natural gas system. Think of natural gas system as being the pipelines that cross the country, supplying gas from the Gulf to many areas. and that those disruptions in the gas industry provide disruptions to electric power. These effects can be felt 4 states away and influence people, which is what this analysis tries to do. In terms of the customers no longer receiving electric power are also customers no longer receiving natural gas for heating, which is important in case of the winter. These are some of the applications of how we think of applying complex adaptive systems thinking and bring the tools that are appropriate for analyzing complex adaptive systems to provide useful information in a planning context. We hope to someday soon be able to have this information in a real-time operational context as well. That's a really hard problem, requires technological advances. So I've come to close to the end of my talk here, and I'd like a show of hands. Who thinks they're a systems thinker out there? Okay, 3, 4, 6. Okay, so that's great, to see that. We need more systems thinking, and we need more systems doing in this entire field of emergency preparedness. Here's some essential elements of a good systems analysis and analyst, by the way. It's a notion of, do you think of a system and how you represent it as a picture? Do you understand what the requirements are for what the system is supposed to do? Do you consider the stakeholders in the system, the people making the decisions, and what processes they go through to arrive at those decisions? What is flowing through the system? Is it energy? Is it money? Is it both? There's always a flow in a complex adaptive system. That's one of the principles. The flow of whatever it is, it gives the system life. It animates the system. So it's important to identify. What are the measures or metrics of what the system is supposed to do so you can tell how well it's doing? What are the resources that are needed to make the system move forward? And again, what are the objectives of what either you're trying to do, the organization is trying to do, or the objectives of the community or all the stakeholders? It's a question to ask. So the bottom line is that we are all part of complex adaptive systems. We need to understand them to anticipate the outcomes of our actions. We need to consider behavior of people and of decision makers in the process, which is something new that we've never done before. We also need to get a repository of how people actually behave in emergencies. We need a repository also of the questions that keep coming about being asked in any emergency at whatever level by the federal, state, local preparedness experts to capture those, because then we can plan next time to have the answers. And then new tools, models, and analytical approaches are an important part in making this possible and moving us forward to answer a lot of the questions that we've never had answers for. Artificial intelligence, data analytics, machine learning, perhaps. Those are other tools that are coming into the forefront that will allow us to at least get a little bit of a handle on predicting outcomes and maybe predicting the future that we can hope to design to have for our society. Thank you. Thanks for that question. This goes back to my course. And what I've done in the course is, in the first assignment, since I'm talking to people who are not mathematicians and things, or modelers and things like that, they're first responders, which are very experienced and very intelligent. And one of the first things is to do a network analysis of your organization. And as I said, focusing on what the decisions are within the organization and what the connections are to external organizations. to identify what information is needed to make decisions, as well as the connections in a larger context of emergency preparedness. And this immediately, doing a kind of a network exercise like that immediately has value because people realize there's gaps. People realize the kind of relationships that they need to establish that maybe they don't have. But in an emergency situation, they need, because those are the people that they're going to call or count on or trust when there's a crisis that is, in the midst of it. So I think that's a good place to start. And then the rest takes care of itself in terms of understanding the factors and the causes for how the system, let's say, will respond or adapt, either the one we're managing or our own systems of management interacting with the system to be managed. I think that this is where it's important to capture what the problems are that are being addressed or need to be solved. The approach that is going to happen is to develop tools or maybe they're apps that allow emergency managers to specifically address those problems as they're occurring, to the extent that they can be, there can be a repository, so to speak, of, as I said, lessons learned or history of how these problems were addressed, and that repository is accessible, indexed properly, however you want to say it, would be a step forward, I think, in just what you're saying. I mentioned Ebola. I was involved in the Ebola task force of many organizations in the federal government at that time as well. And I worked with the organization in town, and they said, well, we just got a call from the White House. We need to know, what the effects are on this or that from the Ebola outbreak, or what we should do, and we only have 2 hours. So, the challenge is to bring any kind of analysis involved into the short time frame that's available to answer these questions. So the best that they were able to do in the Ebola outbreak was to get a bunch of people in the room who were somewhat informed, about past experiences and the analytics that is possible, and to at least talk among themselves and arrive at an answer. So it was in the room, 2 hours, out of the room, got an answer, and then it's shipped off to the White House. The challenge is to do better than that. But I will say also that working with the agencies I was at in the Ebola situation, for the first time, they said they want to know what the modelers think, before they answer the question. So whether we call modelers, analysts, tool makers, whatever, it's a similar thing. It's how we can inform, I guess, we were talking at lunch, intuitive decision making. How can analysis inform that process to improve intuition to a greater extent? It is all about the intervention and just taking some thoughts from the field of complex systems. Interventions can be have big effects with small interventions. So I think one would carefully think about looking at the system, think of a network again, and wondering and thinking about what the effect or where the interventions should take place to see how the entire system could be perturbed to a more desirable state or more useful state. I know I've answered this very abstractly, but it's just that kind of thinking of where, let's say, surgically placed interventions could affect the entire system in a big way. Whether that's more resources to be applied, maybe timing of resources. Resources is actually a big, first step into any kind of analysis of a complex system. We've heard earlier today, virtually all the talks emphasize the need for resources, understanding what resources have to be applied, in an emergency. And instead of just going through the emergency and then finding out what resources could be applied. We can think about it in advance. This requires emergency planners and preparedness people to think outside the box of their organization. And I call it giving permission to people to think outside of their job description. And this is something that is, it's not encouraged in our society. And that's what system thinking is all about.